Hello, everybody. I'm Alex. I'm joined here today with my colleague Teresa, part of the Semantic Kernel team, and we're going to be talking about Copilot Chat. This is our reference sample for anybody, a developer or to an enterprise who wants to probably get started with building their own personal chatbot. And it is our go-to sample for showing off all the innovations, all the new features from the Semantic Kernel core. So without further ado, I'll pass it off to Teresa to give a quick intro of herself and talk about the project.
Yeah, hey guys, I'm Teresa. I'm a software engineer on the Semantic Kernel team. And so today we'll be talking about Copilot Chat. So Copilot Chat is meant to serve as a reference application for Copilot Chat, like chatbots built using Semantic Kernel. And the idea is that someone can take this sample and then build their own integrated LLM chatbot on top of it. So there are a lot of moving components. I know there's a lot of code, so hopefully we can help clear up that confusion today.
Sounds good. Do you want to give a quick demo of what Copilot Chat looks like?
I can do that. Let me share my screen. Okay, cool. So this is the application once you start running it. All the instructions to run both the backend server and the front-end web app are in the readmes of the repository, but I will just give a quick demo on like how this works. Like you can see I've already sent a message here that says, hey, help me plan a trip to Hawaii, and then Copilot Chat like asks for more information on how the bot can help you plan it. So that's like the basic chat component. We also have the option to enable different plugins, and doing this will enable like specific additional capabilities for the chatbot to leverage outside of its just like conversational aspect. So I've already enabled like the GitHub plugin, and then the process is just like you hit enable. If there's authentication required, it will prompt you through that authentication flow. So I'll show like a little bit of how it works here, where if we try to trigger the GitHub plugin, we can do list my open pull request. And I already have this hooked up to the Microsoft Semantic Kernel repository. So it should list some of the open pull requests there. And right now, since the plugin is kind of like an external API capability, it will trigger the planner, and then the planner will be like, hey, like I have this function available. Do you want me to execute it? And then it will just execute the plan as expected. If it was just like a regular chat message, it would have been like what you saw in the first part. And over here, we can like add a bot, join a different bot, or even like upload a bot. So upload a bot comes from like you can download any of your bots or invite other people to your bot. Yeah, so that's pretty much like the gist of it. It works a lot like just a specific like chat interface. And it has like all the semantic kernel like core functionalities enabled in it. Alex, is there anything else you wanted to call out specifically about Copilot Chat?
Yeah, can you just do a 1,000-foot view of the architecture, maybe, of like what it's built with, the technologies used, in addition to the
Yeah.
semantic kernel?
So Copilot Chat consists of basically two different applications, right? The front end web UI is what we're seeing here today, and then the back end API server. So I can do a code walkthrough in a little bit, but the front end application is meant to serve as like the experience that the end user sees, or whatever you expect for your end users using this chatbot, such as like interactions with the chatbot, the authentication to the web app, and stuff like that. And then the backend server takes care of like the hookup to the semantic kernel. So it enables things like invoking skills, generating the intelligent bot responses, and hooking up to your OpenAI or your Azure OpenAI instance. The front end is a React web application, and then the back end is an ASP.NET application.
Very cool. Very cool. Yeah, we'd love to see the code and do a walkthrough of that.
Okay, cool. So I already have these open. Oh, wait, you can see here that the plan completed. And on every chat message, you can see the prompt that was used that was like set to the LLM to get the bot response. Yeah, okay, so now we can move over to the code. So this is the code. It all lives in the semantic kernel repository, and it's kind of like embedded right now, but you can get to it by going to samples, apps, Copilot Chat. And then the main two folders in there are the web app folder and the web API folder, which are named accordingly. So we can look at the web app first because this is the front end. And so the web app like serves just as the client side interface for Copilot Chat. It's just like, as you saw, a user-friendly chat interface that is used to interact with the web service. But I wanted to note that because basically the interaction with the web service is just done through HTTP requests, you can build your client, your front end using any platform. So you can build this as a console app, like a desktop app, a mobile app. We chose to do like a single page web app with React. So like I said earlier, the web app is built using React and TypeScript. And we wanted to create like this component hierarchy that is hopefully easy for you guys to follow. So we go in here, source. All the components live in this folder. The actual like components are rendered live in the components folder. But since this is a single page application, the starting point is in this app.tsx file here. And this kind of like manages the view state. So what you're actually
Okay.
seeing as the end user.
Can we zoom in a little bit?
Oh, yes. And if I talk, I know I talk fast, so you can always slow me down if you need to. Yeah,
great.
so, okay, cool. And then so like this is like basically the like foundation of the app, and it will, depending on whatever like the state is, it will render the appropriate view. So for instance, like it will make sure like the backend's up and running, or it will be loading the chats. And then the chat view is the main view that you were seeing earlier with the whole like chat room chat list. So that's where we are now. And so let's reopen this. So that's kind of like the foundation of that. And then we use Redux for state management. And everything about that is stored in the Redux folder here. And this is where we manage local app state, such as the current logged in user, the conversations views after we've already loaded it from the server, and like authentication headers if the user enables a plugin from the front end. And then the components library is that component hierarchy I was talking about earlier, where you can find, you can find all like the components, the React components that are rendered for the view. And hopefully it like makes sense. We've tried to like modularize it out by building and using reusable components, and everything is well named, so you should be able to trace through it pretty easily. And then we have the libs folder. So the libs folder is the folder that contains all the files for the data handlers. So like the hooks, the models, and the data services that handle making the request to the Semantic Kernel web API application. If you look here, we have like the services. So the services are the data services, and they are the modules that are responsible from fetching the data to the respective APIs. We split it out by domain. So these services handle things like formatting the HTTP request with the appropriate headers that each API needs, such as like authentication headers. And then on top of the data services, we have these hooks called like use chat or use file. And these, in general, like you can think of these hooks as like request handlers for the user interaction. So they're a layer between the event handlers and the data service, and these hooks handle actions that affect app state. And then they use the data services to actually fetch the data. And then they're responsible for managing that data state and any side effects of that fresh data. Do you have any questions so far?
Oh, this is good.
Okay, sweet. So that's like basically the bulk of the web app. It's a pretty standard like React single page application. So I'll leave that there, and then we can move over to the web API, which I already have loaded over here. So this is the bulk of the semantic kernel management. So the web API stores all the files for the ASP.NET web application that provides the web service hosting semantic kernel. It's pretty standard. It's also a pretty standard ASP.NET application that exposes semantic kernel functionality as APIs that can be called via HTTP requests. And let me show you guys real quick from the web app, how we hooked up, where the requests are made for semantic kernel. So like I said, it's in the libs folder, and then the services, and the base service is where all the requests are routed to. But you can see here, like I was saying earlier, it appends the authentication headers as necessary, and then any additional information for the plugins, and then it makes that GET request to the URL that's spun up by the web API. And then we're back in the web API. So it, like I said, is an ASP.NET application, and the starting point is in this program.cs file right here. So you can see where the web host is configured. And here we define and configure the services that are required to support semantic kernel. So that includes things like authorization, specific semantic kernel services, we can go here, like spinning up the kernel itself and registering some of the initial skills that are needed for the baseline functionality of the kernel, and configuring whatever OpenAI settings or Azure OpenAI settings that you guys want to use with the kernel. And then let's go back. And then it also does other things this is where we register, so the semantic kernel services, and then we register the Copilot Chat planner. And that was what was used whenever we were trying to list the pull requests earlier. And then signal are other services that are required just by the application itself. And then it adds the controllers. And the controllers are important because they handle each request and generating the responses. So that's the entry point. But I also want to call out here that it's important to note that the planner is different than the actual semantic kernel that's a part of this web API application. They're both components of semantic kernel, but here they operate as separate services that can work together. The planner actually contains a kernel of its own that is used to invoke the plugins, invoke the functionality that it needs to fulfill a specific user request, but they're two different services.
As in two different kernel instances?
Yeah, so the planner itself is its own entity, and within the planner, which I'll show you whenever we go through the code, within the planner, it has a kernel. So it's two different kernel instances. So you have that baseline kernel that handles all the bot operations, the chat skill that we're about to go over. And then you have the planner kernel, which handles any function calls or invocations that the planner wants to make. So they're separate. So you don't really have to worry about any race conditions there, or just an infinite loop.
Got it. And I guess, and I'm sure you'll probably go into this, but how does, because from what I saw in the Copilot chat, it can sometimes use the planner, right? It can sometimes just respond with the normal chat message. So I guess, how does it decide between those two which ones to use?
Yeah, so it's always going to go through the semantic kernel. So the semantic kernel is kind of the base operation for this web API application. So the kernel will route it to the appropriate controller, and the controller from there will send it to the appropriate skill. But the planner is basically embedded within the chat skill. And whenever the chat skill invokes the planner will then decide if it needs a plan to run or not, which I will go into this in more detail in a little bit, but that's just basically the high level overview of it.
Very good.